Hello. All right, this next section will be about Spark SQL. It should only be about, I think, probably 30 minutes, so. Yeah, this will be a lot less painful than that first section. It was painful to write it, too, trust me. Okay, Spark SQL. I chose this one because I think it's the most relevant. There's 4 or 5 talks that I have that I'm always updating. Spark streaming.
Okay, there's no problem. I am talking about did you get Docker? Just
Yeah, and then some of the machine learning stuff as well too. So if you search through the slide share, like you can actually see some of the other talks. They like haven't changed much. These first 2 have changed a little bit. So yeah, I chose this one because I think it's probably the most relevant. It's what people are going to start doing with Spark right away. They're going to connect their like data sources. Could be JDBC database. Could be SQL Server. Could be Oracle. If you're using Amazon, could be Redshift. Yes, I assume most people use a SQL database of some kind, right? And then possibly files. You've got files coming in, log files that you want to analyze. We'll talk about data frames again. We'll talk about this data sources API, which is kind of a hidden API that's not very well documented. The guys that wrote the Spark Cassandra adapter, they found it. The guys that basically just like taking a look at like the existing stuff that's in Spark SQL for like JSON and for CSVs and JDBC, and then figuring out how to then hook in Cassandra. So we'll actually build one live, just a simple one. We'll talk a little bit about Catalyst, some of the code gen stuff again. So that's why this one goes somewhat more quickly, because I think we've actually covered a lot of this. So again, partitions, pruning, pushdowns, file formats are very, very important, things like Parquet, right? And then, we'll create a custom. So data frames, based on, if you guys know Pandas data frames, this comes from Python, to give you a little bit of Spark sort of historical context. Spark was created in an academic lab called the AMP Lab out of Berkeley, UC Berkeley. These guys initially just kind of, had these concepts and these things, and once Spark started to become more and more mainstream, people were like, hey, this is just like an R data frame, or schema RDD is just like Pandas data frame. So they ended up just kind of picking data frame, sticking with it, matching the existing APIs. So now this is going to let people switch their code over, right? Because you can pretty much one for one grab the same code and just use data frames. In fact, data frame, the Spark version of data frame actually has a method on it that's called toPandas. That'll actually, and then you can also create Spark data frames from a Pandas data frame. Also R has a concept of a data frame. If you think of data frame as just a logical container, or like a container for your logical query plan, that's all it is. And so that's actually, I mentioned before how Python is now just as fast as Scala if you're using data frames versus previously. It's because all Python is doing now is just giving you the ability to create this logical plan, right? This sort of, if you think about SQL, you're sort of declaring what you want to be done, right? That tiny little plan gets serialized from Python process to the JVM, and then gets expanded into all the Tungsten Spark goodness. Catalyst takes a look at it, can then start to optimize, can start to move things around, flatten filters, and then just the results. So all the processing happens within the JVM, and all the results come back through Python. just the results come back. So, yeah, also data frames. I mean, this is true of Spark SQL in general, I guess, but supports, if you have an existing Hive metastore, right? So again, at Databricks, there was one customer of ours whose Hive metastore, so just for those that don't know, if you are, so let's say that there's a log directory, right? There's a directory of CSV files, or like JSON files. You can point to that file or that directory and then create this sort of logical table that, so that's where the metadata gets stored. So that logical table would be all the fields within that CSV or that JSON, where the files live, right? The physical directory structure, or if it's in HDFS or something. So that's where I was saying MySQL gets used, which is why you have to pass in the MySQL, like JDBC connector, because it's actually each Spark SQL command that runs has to contact the Hive metastore to figure out what it's even, like where physically it's going. So if you don't have Hive, that's okay. This tiny little file-based one gets created, and everything is good. But if you do have an existing Hive metastore, yes, like I said, this one customer of Databricks had, thousands and thousands of tables. So that's how many different file directories that they had, right? They had files coming from everywhere. They had chat logs coming in, just the way that their business was set up. And so to actually query the Hive metastore itself took a long time. So there was one optimization that was made in, I think, Spark 1.5, where you can actually now do pushdowns to the Hive metastore itself. So not just to your data, but actually to that like metadata that is describing your data. So, let's see.
Will Spark support Groovy language in future?
Oh, like a GUI type thing?
Groovy language.
Oh, Groovy. So the question is, does Spark support Groovy? I mean, I know of, there's a project for Clojure, right? So Groovy runs inside the JVM, so that's good. Someone might have done that, but it's not a first-class citizen, right? Yeah. So just like Clojure, someone wrote what would essentially be the same type of adapter for data frames. Things got a lot easier with data frames because it's just managing that logical plan, and then if you can like reverse engineer that and then send it in, then it's going to behave. But there's a project, I think it's called Flambeau or something, that is for Clojure. I want to say I heard someone mention Groovy support, but yeah, again, it's going to be built by someone. Right? Like typically, because I know the person that built the Clojure support works at a company that's all they use is Clojure. They really wanted to use Spark. They realized it wasn't that much work to do. So yeah, I like Groovy actually. I think we already saw this slide. Yeah. So a little bit about the historical thing here, Spark and Hive. These guys, so out of the lab, they realized that there's certain things that the larger companies are using. So for Spark to become a first-class big data processing engine, they needed to support Hive, right? That at the time was the most popular. I think Pig was starting to pick up pace. There's actually this project called Spork, which is Pig on Spark. So again, Pig is generating MapReduce beneath the covers, just similar to Hive. But Sharp was really the bootstrap, or the catalyst, I guess you could say, to people could just take their current Hive QL and then port it over and gain all the benefits of Spark. But then very quickly, Catalyst was born to start to do optimizations that Hive, which is MapReduce based, couldn't do. This is a little bit of an obscure thing, but you should always be creating and using a Hive context. It's kind of goofy because it's like, why do I have to worry about this being Hive? But right, like again, if you don't have Hive, that's okay. That small little right, like Hive thing will be created, but there's no reason to be using SQL context anymore. So you should always be using Hive context. In fact, I think at one point the guy who built SQL context wanted to just probably deprecate it or merge the two somehow, but yeah, that's tough because you have a lot of code written to SQL context. This is interesting too. So this actually was kind of a direct result of us at Databricks working with a lot of customers that had different versions of Hive, right? So for example, that one company, that one gaming company with the thousands of tables within their Metastore database, they actually used a version of Hive that was different. So Spark SQL has to get to the Hive Metastore, right? Because like I said, every query has to call out to the Hive Metastore to get the data that it needs, like about the different columns and such that for the files that it's going to search. But that was conflicting with the version of Hive that this particular customer was using. So we realized this was a more generic problem than just this customer in Databricks. So yeah, the open source guys tackled it. And now there's actually separate class loaders. So Spark can stay on its version of Hive, and customers could either be using newer ones or older ones. It doesn't matter. So, basically separate class loaders for accessing internal Spark stuff or the external, right, like user or like customer specific. A little bit more on Catalyst. So just like your SQL query plans, you've got sort of the raw unresolved. That's how you would write it. You would do two separate filters if you want a range kind of thing. Logical plan, so things start to get optimized a little bit. Then physical plan. So they're in the typical Spark SQL, or in a typical SQL sense, there's usually multiple physical plans that are created, and then they're pinned up against each other based on some cost analysis, and then the physical plan is selected. Really, in Spark SQL right now, as of Spark 1.5.1.6, the only cost choice that's made is if you're going to do that broadcast thing that I mentioned before, where it's going to take the smaller country table or state table and broadcast it out to all the 206 nodes, or is it not going to do that? So basically depends on the size of the smaller table. So some other things that the Catalyst Optimizer does, these are probably familiar to you if you've done any database sort of optimization coding or reading or anything. Simplifying filters, constant folding, predicate pushdown is huge. So this is all stuff that like all databases do. In fact, one of the funny things working at like IBM when I joined and I would give this talk, right? These guys from like 30 years, that have been with IBM for 30 years that have been doing DB2 programming, they're like, this is all the same stuff that we bumped our, we kept. Yeah, so they can basically see the evolution of Spark as they saw it, 20, 30 years ago when they were starting to optimize DB2. So, projection collapsing. Also, too, you can hook in. So something Spark in general, but Spark SQL specifically, is starting to do really well is give you hooks so that you can create your own rules. You can inject those rules into different stages, so not just the physical, but you can actually put them anywhere. You kind of have to go and look at existing ones to really understand it. Sometimes when you are implementing these things, these could be developer APIs that could change from like release to release. So just keep an eye on the like annotations. Usually say this is developer experimental or So here, we'll talk about Parquet for a second. This is based on a paper by Google, right? Like a lot of stuff that we're talking about today is based on papers by Google, and then the open source version comes out by some big company, right? This started with MapReduce. Google released that paper in 2001 or 2002, and then Yahoo built MapReduce, like Hadoop. So Parquet started off as a Twitter and then Cloudera collaboration. So Twitter wanted this for space savings. They had a ton of data coming in. They wanted a way to pack that data more tightly. And then Cloudera for their Impala project, which is similar to Spark SQL. Yeah, they needed it too because they wanted to do faster aggregations, right? So seek once. So this is, I probably should put this in the first talk, but this is how you would typically like represent a table, right? Like you have each of your, this is your rows, that row-based. So now take those and flip it, and now put all the column values next to each other. So, and then you can even put in these min-max heuristics inside of each chunk. So one set of value, or one table's values could span multiple files, and then you can put ranges in here so that you can physically skip over disk. If you see that, if you just crack open the first, that header and see min-max, right? See that the values that you're looking for aren't there, and then skip across. But if you're just doing like a sum, you know, you can seek once and just get all the data, and it's nice and clean. So, yeah, also the schema is self-describing, so every file has buried within it the schema. And that schema can change over time, and so Parquet has ways to handle that, right? Like I guess the easiest one would be if you're adding fields, that's pretty easy to merge those schemas, but if you're changing field names, yeah, that's tricky, or changing the type of field, yeah, that's really tricky. So, but there's ways to do it. The term in Spark is merging schemas. There's ways to turn merge on and off. Fast columnar aggregation, supports pushdowns. And then, yeah, excellent compression. So, spend this slide here on compression. This is what Twitter was looking for. They got about 30% space savings. There's this weird thing where if you have, and this is probably outdated now, but so there's a point at which Parquet actually doesn't help you. And it looks like if you're querying for 30 columns or more, that's where having things flipped in that columnar manner doesn't really help, but yeah, kind of a small detail. So yeah, run length encoding. This is all stuff you probably remember from school, right? Maybe from your last interview or whatever. You had to study on it, or at least study up on these. So dictionary encoding, because you know all of those fields next to each other on disk are physically the same type, because they're all the same column. Right? Like now you can do a lot of cool compression, right? You can bit pack, you could, if you have only 8 values, if like Parquet, right, like during its compression period, realizes that you only have 8 different values total, then it can make it categorical. And create a dictionary of just 8 values and then pack them all in so that they're just referencing those 8 values. Yeah, prefix encoding. Okay, so I've got a demo. I could show, actually I think I have the results of the, let's see. Yeah, okay. So I've got slides on it later. I think for time we'll just go through and show what the actual demo shows. But quick note on partitions. So if you know your data use case, which right, like hopefully you do. So this particular data set, I've got, it's a dating data set where people rated each other, and every user had a gender of either male, female, or U is unknown. So this is 3-state gender. It's some like Czech Republic dating site. I don't know. Found it online, but it was different than a movie, or like a movie recommendation site. So chose to go with it. So you can, yeah. So if you know that you're going to be accessing that data by gender, then you would want to create partitions along those genders, right? That way you can, this is physically directories being created, like beneath that parent directory. And then all the files get pushed in there that have U as the gender, or F as the gender. This is how you would do it. So one thing at, right, like Databricks that like we always mention, and like IBM, of course, we tell people as soon as data comes in, those logs, just the first thing you should do is convert it to like Parquet, and then that's where you would specify your partitions as well. So this is the SQL way to do it, right here, and then by SQL I mean HiveQL, and then that's how you would do it with data frame. Partition pruning, so this is filtering out your rows by a particular partition. So it's kind of a fancy way of, just filtering by that. The problem is if you don't partition your data like it is back here, you're going to have to go through the entire data set, right? Because you can't be guaranteed that you've pre-processed and put all the U's into one area. But if you partition, then this is way faster. Yes, I'll actually show you guys different query plans that are generated that are different because of that feature. So column pruning, fancy way of saying, just figure out which columns to return. This is made possible by these columnar storage formats, so we can actually skip over entire chunks of files because we know that they don't contain that particular column that we're looking for. Predicate pushdowns, fancy way of saying filter. Pushdowns, you filter rows. You want to go as deep into the source as possible. So here's an example of that data sources API. This is what we're actually going to build. This is what the Cassandra connector, right, the Elasticsearch connector I've built. So there's a way, so here's your column pruning, and then there's your pushdowns, your filters. And filter is a base. So this is a trait, this pruned filter scan, and this is the method on that trait. And filter is a base trait that's like less than, greater than. It's all the common ones that you think about with SQL. But like you can actually go into the Spark code base and find filter, and then look at everything that it extends, or that extends filter. More about the data sources API. We mentioned this one a second ago. That's the most advanced one, really, because it supports both row and column filters. Table scan, this is the easiest one. That's kind of the basic, just get me all the data. So that's what CSV and JSON do, because they don't. I think JSON now you can partition, but I think CSV is a little bit. You can just get all the data. So the downside is that you're pulling in all this data and then filtering it within your application. A couple other things. Here's your filters. Equal to, greater than. String starts with. If you want to build your own filters, pretty easy. These are the ones that are native. JDBC, JSON, Parquet. There's actually ORC is the other one. So I always forget what it stands for, but I think it's by Hortonworks, right? So they somehow got it into native. Most of the new data sources now end up in this sort of 1.5 class citizen of Spark called Spark-packages. I'll show you guys that in a sec. But they've pretty much frozen what data sources go into the core Spark. Because the problem there is the Spark community realized that so many people were submitting patches and fixes and new data sources and supporting Amazon, supporting Google Cloud. Each time someone submitted that and they committed it, now the Spark people have to maintain it, because sometimes these people would just disappear, right? So the more and more stuff that started going into core, the more technical debt Spark was starting to take on. So they created this sort of, I call it 1.5 class citizen, where you can put stuff that will likely not end up in the Spark core, but gets highlighted anyway. All right, let's see, this might be too small for human consumption here. Let's see. So this is an example of, this may be difficult to see, but basically there's this Cartesian product. So this is joining. This is where someone forgot to put in the join criteria up there. So over here, they just forgot it, right? They were thinking about it. They've got everything set up to have that in, but then they realized their performance is slow, right? So this is something that we saw quite a bit. And so we would show people this explain thing. You know, you can call that, if you call it with true, it's going to dump out all of it. And you actually see it's doing Cartesian. Yeah, so that's a flag, right? That means they weren't expecting to do that. So basically, this is the exact same query, but they're specifying the join. And now you start seeing, join like popping up here in the optimized plan. Here, join inner is none. There, join inner actually has the filter here. Let's see, and then this ultimately leads to a nice join. And we even see the broadcast join being done here. So it's calculated that the gender table is small, right? That there's one record for every user versus the number of ratings is, I think it's like 17 million ratings for this data set. So N is 17 million, but M is a fixed 130,000 or something. So here's the difference between broadcast. I mentioned there's this broadcast threshold of how big, what is the maximum size that the smaller table can be for it to use the broadcast. And there's one thing to point out here, which is, like we see this all the time where people look on disk. So this threshold, this is in bytes. So by default, it's 10 megabytes. I'm setting it there just to be explicit. But they look on disk and see that their gender table is 9 megabytes, and so they set this value to 10, or just leave it set at the default of 10. What they forget is that when that data gets pulled into Java, right, like especially like Tungsten, that data could be 40 megs, right? And so they just assume that they're going to be getting broadcast, right? But they're not, so their performance is crappy. This is the way to be super explicit and actually look and see that. So this is just regular sort merge join. So here I actually disabled by setting it to -1, just to force it to not use the broadcast. And I don't have the times on here, but so this particular data set, it was 4 seconds to run that join, and then a single second to run the first join. I didn't do like a lot of tests, but it's kind of expected that would be slower. So watch out for that. This is one, so partitioned versus unpartitioned. So here's one where, let me just highlight all these. So in green is the partition table. That's one where we've called that partition by, and the ratings I'm partitioning by the rating itself. So each rating 1 through 10 has its own subdirectory with specifically just that data in there that really matches that partition. And then genders is in red because that's not partitioned. So here I'm actually there's two things I'm doing. I'm purposely mixing and matching filter with where. So those are aliases. So they're basically the same thing. So if you use filter, if you use .where. Secondly, I'm purposely specifying 2 knots instead of, so there's 3 states total. There's male, female, and then unknown. And really, I'm trying to get the unknowns, but I'm constructing it on purpose, not female, not male, because I want to show, all these different. This would normally be separate passes through the data, right, based on logical, and then things start to collapse, right? So now, same thing with, I want between 4 and 6. So here it's 2 separate, right? It passes through the data, but then it gets optimized down physically. So the optimized logical plan, it's 1 pass, and it gives it the range, and then it's a second pass, not and not gender. or not mail. And then here, so this is where pushdowns get, so this is where we're able to push down. So because we've got ratings partitioned in green, there's only one line here. So this is, as it's scanning the file, it's gonna, it's going to skip, it's basically not gonna pull in data that doesn't match those filters. So those filters get pushed down to the actual disk itself, the code that's pulling data in off disk. Versus the unpartitioned, which can't take the push down, because it has to search all the data anyway, right? So that's still two passes. That's one pass to get all the data. This is going to create, this is going to create a lot of objects in memory that won't get used, and then it's going to filter it. And then that second slide is the opposite. So I've got ratings unpartitioned in red, and then genders partitioned, and you see how it flips. So this one's really bad because rating has a lot more data, right? This is the 17 million row. So this has to pull in 17 million rows and then filter it. Whereas this is the smaller table. So yes, ideally, I think the next slide has it, you want both partitioned. And you see, yes, everything is green here. So one single pass, they're both partitioned. But you can see they start off, right? Two separate, gets collapsed into one, gets pushed down into the physical. Spark 1.5, I believe, added this nice visualization too, so that you don't necessarily have to look at the explain, but you can actually crack this open. You can see the number of rows going in, the number of that got filtered, right, like the output rows. You can kind of get a sense of the effectiveness of your filters, converting to unsafe. Yeah, let's see. Here's where you can see the peak memory. So this is new too. So you can see the exact memory usage. Right, like again, this is because of tungsten, because of the ability to have byte array byte counts within your byte array. And then you see broadcast hash join being introduced there, so that's something that's good. All right, these next few slides are just different examples of the different data sets, or data sources. So here's JSON, that's how you would do it. I kind of mix and match reads and writes and data frame and SQL. That's on purpose, just to give you different views of how to do these things. The ones that are built in have these nice convenience methods. I think if you're someone creating your own data source, like you can actually create these convenience things as well. Yeah, not all of them have, but that saves you from having to put org dot like apache.spark whatever. And also too, it's worth pointing out that we're actually pointing this file we're pointing to a bzipped file. So this is compressed. And one thing, there was another sort of best practice that we saw kind of come out of dealing with a lot of customers. So, right, like bzip is a splittable, right, like compression, right, like codec. So it can actually chop it up, just like, so similar to like LZF, where it can like operate on chunks and merge things and split things. Right, like BZ2 does this as well. So, but now gzip doesn't. So if you're trying to split this up and have like multiple, right, like servers actually pull this data in, so having multiple partitions, if you don't use something that's splittable, it means that only one partition can be created, and it has to read in all the data. So that's a hotspot, that's a bottleneck. So like a lot of times people said, hey, yeah, we heard that you can use compressed data with Spark. We're not seeing this, we're only seeing one partition being created, and it's because they were using something non-splittable like gzip. So of course the solution to that is just probably do it once, probably take the hit, and then convert it to like bzip or Parquet. Right? because Parquet has its own compression. So JDBC, similar kind of thing, except now you're going to be passing these other like config parameters, like your JDBC connection string. The trick here, yeah, like I said, you have to pass in your JDBC driver onto the Spark class path, the actual system class path. Parquet data source. Yeah, here's some of the configuration parameters. So yeah, always keep filter pushdowns turned on. Merge schema. You want to keep that false. So this is where you have the evolving schema. Not unless you're actually using it, because there's some things that Spark SQL is doing. It's sort of being pessimistic when you have merge schema turned on. Also, too, I've seen some bugs that were kind of around that flag being on. Yeah, obviously those get fixed, but it's just best to keep it off if you don't need it. Let's see. So orc is very similar. Here's that Spark packages thing I was talking about. So this is where if you did create your own like data source for whatever reason, it's going to end up here. So like the DB2 connector, for example, Spark DB2 will end up here. Even some of the like Databricks stuff. So yeah, Databricks, main company behind Spark, they built the Spark CSV. It's not part of the Spark core. It's actually separate. Spark Avro, same thing. Spark Redshift. Yes, I actually worked on that one a little bit. There's the Cassandra connector. Upper right is the Elasticsearch connector. Yeah, so anything too that is like vendor specific or cloud specific, that's not like generic, that's not like open source, is going to end up here. Right? Like things specific to Salesforce. Yeah, even Cassandra, which is fully open source, still it's going to end up here. CSV, Elasticsearch. Elasticsearch tips, I don't know why they're in there. There's one trick with Redshift. You guys use Redshift? Has anyone? Yeah, like there's, right. So, and this is true really of any, I guess, well, it's not entirely true. But yeah, so Redshift is one, there's one master that you talk to within Amazon, and then like behind that, all of the query optimizations happen, all the distribution happens. So there's this trick with Redshift where if you're pulling back a lot of results, they all have to stream through that master, and that's not, so that's a single bottleneck. But here, like you would actually ask Redshift to dump out its data to S3, their like distributed file system, which is kind of like it's a little bit like HDFS, but it's managed by like Amazon. And then from there, then you can pull in parallel, right? You could split it up. So, DB2, big SQL connectors coming, if anyone uses those. Cassandra. The big thing here is pushdowns are done by Cassandra itself, so it knows which nodes to go to, which nodes have the data for the key that you're looking for. If you guys have used Cassandra or anything like it, right, like HBase, so like beneath the covers, there's files, right? There's physical files that back off. Just like any database, right? Like at some point, data is on a file on a disk, and that's being served up by this database. So yeah, so Netflix actually did this about 5 years ago, where they needed to get to the Cassandra data in the fastest way possible for these big analytics workloads that they had against that data, right? So all data at like Netflix basically is stored within Cassandra. So that's all the play events, all the browsing events, all that stuff that's being tracked. They needed to get to that data to pull it into MapReduce, right? So they can crunch it, they can run the machine learning algorithms. And there was only one way to get to data that's in Cassandra, and that's the Cassandra query language, right? We're actually calling select and that kind of thing. Well, that creates a lot of overhead, right? That's going to create a lot of object creation within Cassandra. If you're using that exact same cluster for your live data, which like Netflix was, right, like taking all these, right, like these data points were all coming in. And if you start to run these large queries that are competing now for the same resources that so picture if you do like this huge select at the same time that you're trying to do like 10 million writes per second or whatever it is, that's going to just like completely blow away any sort of caching and things that are going on behind the Cassandra front door. So what they did, they created this project, and I can't say it for the life of me, but it's like a Geethithis or something like that, where they actually go directly to those files that back this data. And they're called SS tables, sorted string table. They're called something in every different project, but they just reverse engineered the format of these files, because I mean this is all open source, so they could look at the code. And they just go straight to those files because this is read only. They're just reading them in and then process them. So they're just running just normal MapReduce. So they're not actually changing anything or like manipulating anything. It was super efficient just to do this. So there's this new. The whole point of this is that DataStax, the company behind Cassandra, is starting to work on this for their Cassandra connector. So right now, the current Cassandra connector actually does go through the CQL front door. But for any kind of bulk analytics, you want to try to get straight to those files. This is the guy that actually runs the Spark SQL project at Databricks. He's kind of a funny guy. He's working on this REST data source, kind of a generic REST data source. So it sort of makes you think about data sources differently. So now you're thinking, it's not just data, but it could be any kind of live. It's going to be data at some point, right? But it doesn't have to be like a database. So if you picture like a REST service as some way to serve up data. So we can create demo 10. Do one quick demo here. So I created this data source. It's just called integer range relation, where I just give it a start and an end, and it's just going to generate data. It's just going to generate numbers 0 through 9. So let's hope it runs. Oh, okay. So I did 0 through 9, and then I'm calling this filter. So I actually built a filter yes, I'm reusing the existing less than filter. So if I get rid of this, it should just give me all 0 through 9. If I do show here. Yeah, there's 0 through 9, and then I'm going to filter it. There's the filtered version. So very easy to do. Yeah, you can insert data. So I'm going to add data. So there's 0 through 9, 20 through 29. And yeah. So the code for that, let me show you the code. Okay, so here's that base relation, and then these are the pruned filter scan. That's for the pushdowns, the column filters. There's that method right there. That's where I'm taking in the required columns and taking in this list of filters. Let's see. So this is where I'm looking at all of the filters that have been passed in. and I'm applying the filter. So if it's greater than, then I'm gonna do some Scala magic there and filter out anything greater than. Let's see. Yeah, so that's it. That would be for creating a custom data source. A few more slides. Yeah, again, when you are done with your data source, you put it in Spark packages. This is something people don't, or it seems to me people don't really know too much about. You can treat Spark like a database. Yeah, I was talking to someone at the break about how you really don't want to do that, especially on the user, right? Like, think of like the application. If a user is like starting to like interact with the application, right? Like, you don't want data or Spark to be on that hot path, that request like response hot path. You want to still treat Spark as sort of an analytics batch kind of thing. It does have Spark streaming, which kind of gives you the idea that maybe it is more than that, but yeah, it's safest just to treat it like that. But you can actually connect things like Tableau and like MicroStrategy, and there's this JDBC, like ODBC thrift server it's called. It's a fancy way of saying I could start up a process that I can connect to that will understand JDBC, and then I can run queries. The problem is that like you don't want to start to return a lot of results back, because it suffers from that same problem that like Redshift suffers from, which is the single master. So if you are streaming back large amounts of data, that's not a like best practice. This is more call into Spark, do some kind of like aggregation, do a sum, do whatever you're doing, and just return those simple results back, right? Those thin results back to something like Tableau. So I can show you. This is the last demo, by the way. So here we're going to yeah, it looks like it was already running. So you would start that. That's going to listen on port 10,000. You could start up Tableau. This wasn't totally working for me earlier, but we'll try it anyway. Select Spark SQL. Oh, actually, here's the... Oh, there's a problem connecting. Search table. So, if you were coming in for the first time, you would do like a new Tableau session here. You would select Spark SQL. Yeah, like Databricks worked pretty closely with these guys to get this working. So something's going on with my port mappings, but normally you'd be able to just point to this guy, spark.com. Port 30,000. Username. Okay, found it. So we'll do show tables here. Oh. Type it. Ooh, what's going on? Anyway, yeah, you should be able to. Yeah, so there's something going on, but. Ah, okay. So I think with Tableau you can kind of like drag and drop here. And then, yeah, you would set up the join clause. Yeah, that kind of thing. So, yeah, this is actually connecting in. Yeah, so you can create temp tables. Yeah, you could do all kinds of stuff here, but these are tables that I've created that are in the Hive metastore, but these are physically files. All right, like dating underscore genders, I created that. So if you remember, yeah, I mentioned the Hive metastore. You can actually point to these. So where's the dating one? Yeah, you can actually point like to these physical, right, like movies.csv, bzip2, and then but give it explicit. You would say that the type, which is CSV. So here's a type. And that's using Spark-CSV from the Spark packages. And then you define the actual schema and give it the physical the file location on disk. And then that basically creates a table that's registered with Hive from a file. Right, but again, CSVs don't support pushdown, so you don't really want to use those. You would want to use Parquet if possible. So that's it. Any questions? I think you guys saw the links there. There's some, yeah, this list got bigger and bigger. What's coming for Spark After Dark 1.7? I'm kind of between 1.5 and 1.6 right now, but yeah, I talked to someone at break about trying to use auto scaling with Spark. So this is where throughout the day there could be lots and lots of things being queued up because you have a lot of users, your own, right, like analytics users, people within your company that are using the Spark cluster. You want things to auto scale up. Something we're starting to see more and more of is people having this hybrid environment where they have their own data center that has a fixed number of nodes. And then they want to use EC2 or right, like Google to start to auto scale. So they're using the same Docker image between both. And as new things come up, they get registered with Spark. The Spark master now knows about them and then can start to like hand off tasks. But then from a cost saving standpoint, when people go home, 5 p.m., 4 p.m., 6 p.m., whatever, you start to scale this down. And then as far as flux capacitor, the advanced Spark stuff, just working on more and more notebooks. Might actually try to get IPython working again. And then some, just things that we're working on with Databricks and Netflix and Brendan, Greg, and those guys is actually taking Spark itself and running it through these profilers, through perf and flame graphs. So, yes, anyone going to Strata in Singapore? No. Cool. Yeah, that's it.
Thank you so much. Is there any question for Chris? No? Okay, thanks for coming. So,
Thank you for coming, yeah. Thanks for having me.
if you are